This video describes some of the properties of hydrocarbons and how these properties are used in the oil and gas industry. Hydrocarbons are all non-polar because they contain no lone electron pairs. Since the molecules are non-polar, there are only one type of intermolecular forces. These are the London dispersion forces, which are very weak. Hydrocarbons are all nonpolar, so they are not soluble in water, but they are soluble in other nonpolar substances. This is why oil does not mix with water. The weak intermolecular forces also result in low melting points and boiling points, though the temperatures of melting and boiling can vary depending on the length of the parent chain and the amount of branching and saturation of the molecule. As the length of the carbon parent chain increases, there are increasing amounts of London dispersion forces. These increases result in higher melting and boiling points. This is why some hydrocarbons are gases, like propane, which is used to fuel barbecues, while some hydrocarbons are liquids, like octane, which is used to fuel cars. Some hydrocarbons with really long carbon chains are even solid at room temperature. Here you can see the increasing melting points and boiling points that are observed as the carbon chain length increases. The amount of branching on a hydrocarbon can also affect the melting and boiling points. Straight chain hydrocarbons have strong dispersion forces and therefore have higher melting and boiling points. Branched hydrocarbons have weaker dispersion forces and therefore lower melting and boiling points. Having unsaturation or double bonds can also impact the melting and boiling points. Any molecules with double bonds do not pack together well, and so they have lower London dispersion forces than alkenes. This results in lower melting and boiling points in alkenes than in alkanes. Fossil fuels are found naturally in many different forms. These forms include natural gas, coal bed methane, crude oil, heavy oil, oil sands or bitumen, and coal. Fossil fuels need to be processed to become useful products. Once processed, fossil fuels may become ethane, propane, butane, jet fuel, plastics, and even synthetic fibers. Alberta is very rich in fossil fuels. Many people work to extract, transport, and process fossil fuels. Fossil fuels are believed to have formed from sand, silt, and plant and animal remains millions of years ago. Although some of the natural gas may be burned directly or exported as a mixture of gases, most of the natural gas consumed in Alberta is further refined into separate components. The first process that we are going to look at depends on boiling points of different hydrocarbons. Remember how the boiling point of hydrocarbons increases as the length of carbon parent chain increases? We use these differences to help process fossil fuels. This process, which we call fractional distillation, uses a large tower to essentially distill the fossil fuels. In traditional distillation, a liquid is vaporized and condensed. Fractional distillation does this with large quantities. Crude oil is brought into a fractional distillation tower, which is heated from the bottom. The heat will cause the different components of the fossil fuels to vaporize or evaporate. There is a continuum of different temperatures in the tower. Toward the bottom of the tower, the temperature is hotter, and towards the top, the temperature is cooler. Different components of fossil fuels are going to condense at different temperatures depending on their carbon chain length. Substances with higher boiling points will condense in the lower, hotter trays, and substances with lower boiling points will condense in the higher, cooler trays. At different levels, the substances that condense are collected. The substances that are withdrawn are called fractions. We will be examining more ways that hydrocarbons are utilized in class.